All right, it's Chinese kit time. It says made in China. This is a 13814 kit. That's got an LED. Let's get it onto a tray. Oh, lots of parts. Lots of parts. That's always a good thing. All right. Good PC board's thin. Usually the boards are, standard boards come in different thicknesses. And normally you get them, they're about 62 thousandths of an inch. And this looks like it's a little more than that. These are 1.6 millimeters. This is probably a 1 millimeter board. So it's a little unusual to see kits made with thin boards. But usually the way that you just put things through the fab is whatever they're running that day, that's what you get sometimes. So I don't know. There's really no reason to have specified a thin board. The price is the same, and there's really no advantage to it in this particular case. So yeah, I don't know. It's interesting. What do we got here? We got lots of LEDs, lots of little individual transistors and stuff. So it looks interesting. And the LEDs are in a circle. So does that mean they go around in a circle? I don't know. Let's build it. All right, let's start with the low stuff. We have a lot of resistors to put in. And all of these resistors are 1K. So we've got like, I don't know, 2 dozen resistors, all 1K. Interesting. Oh no, there's no markings on the board of which values go where. Luckily, all the values are exactly the same. So that's interesting. We might have to find the instructions for this thing because it doesn't say what goes where. Like, there's probably NPN and PNP transistors. So yeah, before we get started here, let me cheat and look up and see what this thing does. All right, this thing is really strange. This thing is really strange. There's a 555 that runs 17. It goes in sequence, so it's going to fire 1, 2, 3, 1, 2, 3, and it's going to light up his LEDs. It's supposedly simulating a 3-phase motor. And then it's got this really weird section down here that's completely separate. And I think this was built to test people on fault detection. So I don't know if there's like a built-in error in this particular thing, or I don't know what's going on. Anyway, I found enough information to build it. So here's the parts list. So yeah, let's build it. Went to a plant store today. It's time to put some plants in the backyard. And got lost. It's driving for about 10 minutes. I'm like, I think we're going the wrong direction. Luckily, my car has a GPS in it, which I wasn't using on my way home. I figured I knew my way home, but I got turned around and looked down, and my car said it was headed east, which is not the way to go. I think I'll blame it on COVID. I've been stuck at home for such a long time, I don't know how to navigate back. I'm like a bee colony that got lost. My friend got some bees. That's pretty cool. His neighbor had some bees and he was fascinated by them, so neighbor gave him 2 hives, and so now he's got these bees. I like bees. All right. I think I need to start soldering some of these down. I think I have put too many in. All right. Seems like all of the nurseries have shut down around here, so we have to drive a while to find a good one. About a half hour away from here. A really nice one though, oh my goodness. Super, super good one. Not cheap, they never are. Everything's more expensive than I think they should be now. I've calibrated myself. I am always off by a factor of 2. Everything costs twice as much as I think it should, so I don't know what year I stopped calculating correctly, but had my car worked on, twice as much as I thought it should be. Had some plumbing done, twice as much as I thought it should be. That's definitely one of the signs of old age. Losing touch with reality. Like those people who go to the restaurant, tip $1, figure that's enough. I do not do that. Oops, got some resistors sticking up in the air. Yeah, close enough. Optics seems to still be popular. I get, last couple weeks I got some job offers for legal work, and director of engineering, blah, 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 blah. No thanks. Been there, done that. I even got a t-shirt once in a while. We went to a city called Livermore, California. It's where Lawrence Laboratories is designing nukes and other things of mass destruction. Found a real nice sandwich shop though. It was very tasty. There's an airport there too. I used to fly there once in a while. It wasn't a very favorite airport of mine though. There are some wind turbines up on the hill though. And flying around wind turbines in an airplane's kind of cool. They look really interesting from the air. They look interesting from the ground, but you get up above them and see a big installation of a whole bunch of them. It's pretty spectacular from the air. Don't want to get too close because you're breaking the law. All right, we had a dog disaster. He decided to eat some tomatoes and ran around the house with a box of tomatoes and decided to squish them in the living room. Had to go clean the carpet. Oh, the joys of having a dog. We got the dog, the very next thing we bought was a carpet cleaner. So we saw it coming. The leads are pretty bent on this thing. There we go. I think tomatoes are okay, but the tomato vines are very poisonous for dogs. Probably poisonous for us too. Wasn't the tomato plant part of the nightshade family? For a long time, nobody would eat tomatoes because they were deemed to be very dangerous. Oh man, this kit has just leads just all bent to heck. Bent, bent, bent. I heard my soldering iron timeout. Turn it back on. Wow, these leads are bent. Makes you wonder why they put sockets on these kits. I mean, they really expect you to like keep this thing forever, and it's like 10 years from now you might have to replace the IC, and I don't know, maybe I shouldn't put the sockets on. Maybe that'll be my new thing. Sockets? We don't need no stinking sockets. Don't need no badges, man. Maybe if I don't put the sockets on, the federales will come after me. Okay. Gotta socket that 555 just in case. Just in case. Have you ever had a 555 go bad? I don't think I've ever had a 555 go bad. Ever. Even after abusing them. Wiring them up wrong. Overvolting them. Whatever. I don't think I've ever killed one. Don't think so. All right. So there are two types of transistors. They call them diodes, but I believe them to be transistors. An 8050 and an 8055. This is an 8055. And it goes in VT7. VT, that's also interesting. VT7. Vacuum tube? VT? VT. I don't know. VT7, it's right there. And the other 8550, also called the diode, is VT8. VT7, VT8. Maybe some really, really old guy designed this with vacuum tubes in the old days, and they upgraded it to transistor design. I doubt it. I do not think so. I don't think anybody has any business designing a dumb little circuit like this. I don't think so. But we can build it. Once it's designed, we can build it. All right, now I think everything else is a 8050. 50s instead of 55s. We can put those all the VTs in there, VT11s and VT10s. VTs. All our little happy transistors. I'm going to put them out of order, but you can put them in order if you want to. Just so long as you solder them all in. Sometimes they get a little bent, but that's okay. They'll still work. I won't be judgmental. I'll still be happy. All right, let's solder some down. So don't pay attention to my soldering. You might solder better than I do. Got a chunk on there. To figure out how many pounds of solder I have gone through. At home, not at work, at home. I think it's 1, 2, 3, 5, 8. It's at least 8 pounds, probably closer to 10 pounds. Probably. 10 pounds of solder. I used to have one of those really big rolls. Those, I think they're 5-pound rolls. I had one of those for a while. It's gone. This one's about gone now. I bought about a brand new one. Here's a brand new one. Isn't that pretty? Yeah, brand new 1 pound of solder. You can get in there. There we go. Oops. Tighten it down. It's more than 10 pounds, but 10 pounds in this garage. Let's put it that way. I didn't get to do any electronics yesterday. I had to do plumbing. Putting in a new pipes in the backyard, and I had a plumber come out and put in a new faucet. He needed to crawl into the house and tap into the old copper and bring one out in a different spot and everything. I had him do that. But I did all Schedule 40 stuff, so that's more my speed these days. I can do the Schedule 40. It's a lot like soldering. It's more like gluing. Yes. I don't know if there's a shortage or not, but I went to Home Depot and I bought all of the Schedule 40 that they had. I only needed like 6 pieces, 10-foot sections. But I bought everything they had. So I don't know if the next guy can. Had to go tell his wife, well, I can't do that project you wanted to because they don't have any Schedule 40. And he might have been very sad or he might have been very happy. I don't know. That doesn't look good. That one looks all, there we go. Always inspect your work. Make sure your fillets look the right radius, nice and shiny, wetting to the lead, all that good stuff. Oops. All right. How are we doing here? I have one left. I had a couple of viewers like my optics talks, but not many people. If I really wanted to get viewership, I would just stick with ham radio because that's where I get most of my viewers. Sorry, I'm not going to do that. I'm going to do what I want. And you will get a mix of old and new and RF and analog and digital and microprocessors, and gals and pals, all that stuff. Whatever I feel like. Whatever I feel like that day. Okay. Let's see, there's some capacitors. I used to have a friend call them capacitors. Capacitor. Let's see, this is a 100 microfarad capacitor. It's C3. There's C3 down that way. And I assume this one's C2. Well, the rest of the country has been told they can go around without masks now, but in California, we are still being cautious and waiting until June 15th. So, everybody in our household is now fully vaccinated. That's a good thing. CRISPR technology. My daughter says she did some CRISPR when she was in school. That's pretty cool. Not the whole thing, but just the beginning of the sequencing part. Oh, let's see here. What's next? There is a little bitty capacitor. I think that's probably a timing capacitor. I would imagine it's sitting around the 555. There it is. that cute little capacitor. We won't judge him for his size. He's just as important as the big ones. Maybe more so. Okay. All right. And we have a bunch of, interesting, the LEDs are labeled plus and minus. Very cool. Never seen that before. Plus and minus. Works for me. These look like very cheap LEDs. LEDs are amazingly cheap. They used to be so expensive when they were new. Super, super expensive. I think I talked about before, I got some of the very, very first laser diodes working on a barcode project. Got some red laser diodes. They were $500 each. 500 bucks. I think they're probably less than 50 cents now, right? Maybe less, maybe a dime. I don't know. Okay, let's make sure they're all seated. That looks good. Yeah, $500. Made by the big boys, you know, Sony and Panasonic, Hitachi, all the big boys. I designed my own circuit for driving them. They have a photodiode in them, so you can't just turn them on. They'll run away and blow up. So you need to have feedback, keep them at a constant level. And there's a built-in photodiode. So they're three-legged devices. There's a ground and a positive for the LED and a positive for the photodiode. And you have to put them in a feedback path. Monitor their currents. I don't remember how much LEDs were when I first joined in 1980. I don't know what an LED cost. They weren't cheap. What are we missing? What are we missing? Are we missing anything? We have these funny things here. I still don't understand those. We have the LEDs over here. Let's take a look at these. Let's take a look at the schematic. These are called HP1, and they're laid out really weird. J1, J2, and a weird surface mount. I don't know, it just looks weird. HP, oh, there's switches. HP1, HP2, and HP3. HP1, HP2, and HP3. Oh, you can solder bridge them. You can solder bridge them. And then J1, 2, 3. Yeah, I think this is probably a learning tool. And so there are different test points that you're told. What if you don't see anything? So we can. Let's go ahead and do that. Let's go ahead and pretend that that we're a class, and we were just told to troubleshoot this thing. And we will see what works and doesn't work, and then we will try to fix it. All right, so this is the part of the circuit that had the switches for the forward, reverse, and stop. And this is the description of this kit. The electrician training circuit was simulated by means of pure electronic circuit. At the same time as the electronic skill training, electrician training was carried out to realize the purpose of high-efficiency training of electronic and electrical integration. This kit has 2 faults and can send word completion questions and reference answers, which can be easily and flexibly modified and combined, suitable for various levels of competition, examination, training, and so on. Fault test point symptoms. Press the forward button. The analog motor can rotate but cannot lock itself. Troubleshooting. According to the circuit principle, the forward rotating self-locking circuit is composed of VT7 and VY9. Okay, VT7 and I think the VT9. So these two. Okay, so these 2 transistors are and peripheral resistors. When SB2, this one, with a switch here, is measured, the VT9 can turn on. Okay, so here's the path for VT9 to turn on. Okay, and the voltage across R11 is high. Okay, indicating the connection between R11 and VT9. The circuit is open. The circuit is open. Oh my goodness. Okay, and then fault point. R11 and VT9 connection copper foil open. Fault phenomena. Press stop button is invalid and cannot stop. Troubleshooting. According to circuit principle, the reverse stop bubble of the circuit. So there's 2 things wrong. The forward button is funny, and the stop button is funny, I guess, and you're supposed to figure that out and put a jumper where there's missing copper. Interesting. So, well, let's go take a look. Okay, so I have this circuit figured out. Whoa, almost spilled my drink. Okay, let me get something to point with here. Let's go through this circuit, and it has a 555, so if you examine this point here, there's a jumper on a test point, J7, you'll see a clock happening, so that's the first test you would make, see if that's working. There's a test point here to see if voltages are correct. And then, so this thing clocks and sends it through this, and this thing's going to be a counter, so it's going to basically engage 0, then 1, then 2, so it's sequential. It'll go dot, 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 dot. So it's going around and around and around, it's going dunk, dunk, dunk. And then when Q3 happens, it comes back around and does a reset. So it's going to go dot, 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 dot. Going to go round and round and round. So these are really nice chips, these 4017s. I've used a bunch of those in the past. They're great. Okay, so there's a switch here that's just traces on the PC board. But basically, if you put a scope here, you'd see it go flash, 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 right? And then forget this for now. That goes into these LEDs, so it should go flash, 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 flash. So it'll do a sequence. Now, these transistors are used as relays. They're basically switches. They're on-off switches. So if this side is energized, then the signals will come through. If this side is energized, then the signals will come through, right? When the signals come through here, they go dot, dot, dot. And when the signals come in through here, they go dun, dun, dun. They go backwards. So this should spin one way, or it should spin the other way, depending if you have this group energized or this group energized. So these are just used as switches. Kind of clever. And then this is the start, stop, forward, reverse, and stop. So if you hit the forward button, there is a latch here. It latches it, and it'll keep going in the forward direction. If you hit the reverse direction, it's a set, reset, a flip-flop, right? So one side will be energized, and then the other side will be energized. It'll go back and forth. So you hit forward, reverse, And the output of those two flip-flops go here to these two guys. And then there's a master clear, which is the stop, which resets both flip-flops, puts them both to 0. And yeah, let's take a look at it working. Oh, so the kit is sold as a educational tool to find troubles. All right, so there's a couple troubles in this circuit. There's a couple missing traces, and you have to find them, and you have to repair them to make this thing work. So that's the way that this kit was sold, as a tool to repair. And so you had to repair it. Now, my kit was bonus. My kit was special. This switch here was bad. So the little, where is it? Yeah, the little push button switch I had was a dead one. It was always engaged and never released. And so I had double troubleshooting or triple troubleshooting. There's two faults. I had 3 faults. So I definitely got my money's worth out of this thing. So let's take a look at it operating. Okay, so we have power applied. And this is the forward button. So if we push the forward button, it goes in the forward direction or in the clockwise direction. If I hit the reverse button, it goes in the reverse direction. And then if I hit the stop button, it clears it. So that's the way it should work. Forwards and backwards, and clear. So if you have it working correctly, that's the way it will appear. So it's a nice little kit. They're kind of sold as an unusual title. And it's interesting that you are sold a kit that's purposely broken. So I really like this kit. I really do like this kit. So if you're in for the challenge, don't look at the solution because the solution comes with it. Try to troubleshoot it yourself. I had a fun time. Let me go back to the schematic. So I had a fun time kind of reverse engineering this, trying to figure out what it does. Because I had a stuck switch. See, this switch on mine was stuck all the time, and so I couldn't figure out why it wasn't going correctly. Not only was it enabling this side all the time, it was always clearing this one all the time, and it just wasn't working well. So the way that I troubleshot the thing was to lift one end of some resistors. So if you want to open up the circuit, you can just lift one end of the resistor and kind of remove part of the circuit. And you can kind of separate things to do troubleshooting. So that was the method that I used. But it's kind of a neat little circuit. Just this portion of it is nice to learn that you push the button, it turns on this transistor turns on this transistor keeps this transistor turned on, and so it's a cute little circuit. So I don't want to tell you any more than that. Yeah, buy the kit, try it out, see if you can troubleshoot it.